Today, we will continue the same chapter, periodic table, and today's topic is trends in ionization energy. In the previous class, we have read about that ionization energy depends on two factors. First one is atomic size, and second one is nuclear charge. Trends along the period. Now, if we consider second period, that is from lithium to beryllium, then it is boron, then carbon, then nitrogen, oxygen, fluorine, neon, and its atomic numbers are 3, 4, 5, 6, 7, 8, and this is of 9, and neon is at 10. And if we consider its electronic configuration, 21, 22, 23, 24, 25, 26, 27, 28, just like this. So, K and L, the number of shells remaining same, and the number of electrons is being filled up the last shell, that is the shell L. So, as the number of electrons are being increasing, hence number of protons in the nucleus is also increasing, and so nuclear charge is increasing. As the nuclear charge increases, then there is much pull of nucleus, that is the protons, towards the electron, that electron density. So if the nucleus attracts much, then the electron density becomes closer, it contracts, and the electron at the outermost shell will also be closer towards the nucleus and hence more tightly bound. And so the required amount of energy to pull it out will be greater. So as the atomic size decreases, the electron coming closer to the nucleus, it requires more energy to be pulled off, and hence ionization energy increases. And the trend is actually same for the third period also. If we consider the third period elements, the ionization energy of sodium being the least, then magnesium, then aluminum, then silicon, then phosphorus, then sulfur, then chlorine, then argon, right? Sodium being minimum, and along the period from left to right, as the size decreases, remaining the cell number of cell constants, then ionization energy increases, and as we reach it at argon, then there will be the maximum ionization energy because it has the maximum number of protons in this third period. So the maximum nuclear charge it is realizing. Okay, so argon has the maximum ionization energy. Next, the trend along the trend down the group. Okay, so trend down the group, how it would be? There were two factors, right? Nuclear charge and second one was size. As we move down the group, okay, now if we consider group 1, how it would? Hydrogen, then lithium, then sodium, then potassium, then rubidium, then cesium. Okay, so down the group, what we can see, the electronic configuration is like this. 1, that is the K shell. Next 2, 1, that is the L shell. Then 2, 8, 1. Okay, then 2, 8, 8, 1. So it moves like this. So the number of shells is increasing, right? Number of shell increasing means this would be like this, right? The size is also increasing. So down the group, size increases. So as we move down the group, size increases. Nuclear charge also increases because there is increasing number of protons and electrons as the atomic number increases down the group. Hydrogen has 1, lithium 3, sodium 11, potassium is there for 19. So these are increasing, and down the group rubidium, cesium also increasing. So nuclear charge increases. So size increases. The size factor increases. That means from the nucleus, the outermost shell electron being far away. So as it is being far away, the least energy is needed to remove it, right? It is less tightly bound. So ionization energy decreases for this factor. But down the group, as the atomic number increasing, the nuclear charge is also increasing. So nuclear pool increases. If nuclear pool increases, there will be greater amount of energy needed to pull it out, right, the electron. So ionization energy increases. So these two factors, that is the nuclear charge and size, results in the opposite direction for ionization energy. So these two opposing factors, which in between these two, which will predominate? Here the size factor predominates. As the size factor predominates, that the ionization energy will decrease down the group. So for group 1, we can have just like this: hydrogen being the maximum, then lithium, then sodium, then potassium, then rubidium, then cesium. So hydrogen being max, cesium being minimum for ionization energy. Group 1 is like that. And what will be group 2? It is same. Beryllium, then magnesium, then beryllium, magnesium, calcium, then strontium, then barium, then radium. So down the group, as the size increases, the size factor predominates the nuclear charge, and hence the ionization energy decreases. So for the whole periodic table, what we can conclude that along the group, that is, if we consider hydrogen, then it is here helium, right? That is for group 1, 2, 3, 4, 5, 6, 7, 8, 9 is like at 18, group number 18. So if we move down the group, ionization energy decreases, and if we move along the period, ionization energy increases. So at the 7th period, this is for group period number 1, and hence it will be 2 for lithium, and then this way rubidium, cesium is at period number 7. So period number 7 cesium will be of least ionization energy, whereas along the period, as helium being at the rightmost element, so ionization energy here maximum, okay, in the whole periodic table. And from helium down the group also ionization energy decreases, because helium at the topmost in this 18 group, and down the group helium, neon, argon, here also ionization energy decreases, right? So helium being maximum ionization energy possessing element, whereas cesium being the minimum ionization energy possessing element. Okay, so in this whole class, what we have read about, that there are two factors, atomic size and nuclear charge, which actually contribute to the ionization energy, and along the period, actually nuclear charge is the factor which holes. So along the period, the number of cells being same, nuclear charge increases, atomic size decreases. So the tightly bound electron needs more energy to be removed off, ionization energy increases. Okay. And down the group, as nuclear charge is increasing but the size is also increasing, these two opposing factors actually fight in between each other, and the second factor predominates the first one, that is the size. As increasing in size, the outermost electron is loosely bound, and so ionization energy decreases. So down the group, ionization energy decreases. Okay, these two things we have read about in this class. And the next class we will have the three types of ionization energy: first ionization energy, second ionization energy, and third ionization energy, and how the values of these three differs from each other, what is the trend. And to be updated and to see our next video, please subscribe our channel. Thank you.